as the computer. Many of us possibly wouldn't be able to operate in life without this machine, yet who knows how to build this? Do you know how to build this machine? It is made out of materials we don't know where they come from, we don't know the processes that create it, we don't know how it goes together. What is all that stuff? Some of us might understand the basics of how it works, but where do the polymers come from? Where does the metal come from? And sometimes, more importantly, where does it go? So without the processes that create this and dispose of it, we are kind of hamstrung without those processes. Even though this tool gives us so much power, we end up being powerless without the processes that create it. So we all know the expression, you give a man a fish, he's fed for a day. If you teach a man to fish, he eats for a lifetime. But
we actually wanted to take that a little bit further and say, if you give a man the blueprints for a fishing rod, then he can make more fishing rods. So an effective design innovation doesn't necessarily need to be complex. And in a village where children go and gather water and they carry them long distances, this really simple design of taking a water barrel and turning it on their side rather than carrying it on their back makes it a lot easier to transport water. And also, as an addition, it also compacts the soil.
This is a water pump that's actually powered by children playing. And it's a very simple concept. And it can be replicated because of its simplicity, and it actually gives people the power to provide their own renewable resources.
This is another really amazingly simple concept. It's a grip clip where you can take any type of membrane and attach it to a structure. So you can use tarp and attach it to a beam, and it makes it possible for anyone to create a structure. These three things were all taken from a book called Design Like You Give a Damn, where it looks at different methods of using low-tech innovation, which all of these things were in the back of my head when I went to Rio de Janeiro a few years ago to do a sort of a design exercise with school. And I was really struck by the favelas there because there are all of these amazing ways of creating architecture with just objects that are sitting around. And I wanted to build on this idea and propose something that would provide a better medium for the people that could then create their own architecture that would suit their specific needs. And I believe that our proposal was to develop a building unit that could be made from recycled goods. This is a sort of a standard building unit. So the people in the favelas could collect glass and plastic recyclables and then bring them to one place where they would be collected, then reformed using sort of conventional industrial techniques and made into this unit. We developed a very intricate bartering system where people would bring them in, they would bring some home, and they would leave some here. So what it left was, around all these industrial machines, this iconic community center could then be created around it. So it was creating building materials for the favelas, as well as creating this community center for the community as a whole.
Recently, we submitted 2 designs to the Schuylkill Center's Gimme Shelter competition, in which there were, the idea is to design woodland sustainable shelters that would house 4 children for a one-night stay. So the first of these submissions we called Reshelter, which uses Gabion technology, which is very simple and is used to stabilize the sides of highways most of the time filled with stone. We wanted to fill it with recycled materials and highlight the beauty of those whole waste materials.
So this sort of takes the concept of eco-assemblies, which I showed you before, but removes the industrial portion and makes it possible for anyone to replicate. The effect, however, is actually it can be both educational and beautiful. You know, you can look at it and see how many soda bottles did you go through in a week or the base structure there is created with fill from on site, and that's what you would sleep on. And then the towers that are next to it could be filled with glass bottles or plastic or something that's translucent that would reflect the light down into the shelter.
this submission is we call it Rain Sail, and we are actually this was the final submission, and we'll be beginning construction on this this week. And this includes a lot of the concepts that we talked about before, using simple construction and reused available materials.
So the basics are cable structuring, which is used, arborists usually use, reclaimed billboard material, which we're getting from local suppliers. It's vinyl tarp that's typically thrown away, and these hydroelectric generators, which we just learned how to make.
You had asked us a few months ago, how do you make a hydroelectric generator? We would not have known, but it is actually pretty simple. If you just take rare earth magnets and spin them past copper coils of wire, you end up with alternating electricity. And we wanted to build something that would talk about how simple this technology actually was by using clear plexiglass to show the process. So this shows what it would be like to be inside the shelter. You can see the billboard canopies above, suspended by cables, and that would funnel water down to the generators, which you see sort of in the middle of the drawing. And the end of the water would go to a rain garden, and deer fence would create an enclosure around the hammocks, which is where you would sleep.
So this concept uses a lot of what we were talking about earlier. It uses the billboard materials, which is an everyday waste, and they're suspended from the trees in such a way that they have a minimal to no footprint whatsoever, and they are educational as well.